Hello, it's Duncan. Our type-driven 10-pin bowling simulator is pretty much done, but I still have a nagging doubt about whether the scoring is correct. At the moment, the tester scores are based on some example games that I dreamt up, plus a single test that all strikes score 300, and a property-based test that if we never roll a strike or a spare, the score is the sum of the rolls. In order to have full confidence, we definitely need more tests, but manually creating them and doing sums to work out what the score should be would be tedious and error-prone. Computers are supposed to save us from tedium and errors, and I've seen a lot of people using AI for test generation, so today I'm going to ask AI Assistant for help. The results are interesting, but not yet good enough. So I went back to property-based testing and found a way to combine jQuick with AI-generated code that gives the confidence that I wanted for very little effort on my part. Before we go on to testing scoring, our property-based testing last week revealed a bug. It didn't actually fail a test, but I happened to notice that we were rendering the final frame wrong if you scored a strike with the first ball. So as well as a bit of a tidy up, I wrote this test, which is for rendering a final frame strike followed by misses. And you can see here that we failed. So we rolled a 10 and then a 0. We should have an X and then a gutter ball, but what we've actually rendered is an X and a slash. Now that slash shows a spare. It means that the two rolls have added up to 10. Well, the two rolls have added up to 10, but only because this first one was a strike. And normal frames can't be a strike and a spare, and we put the X in the second spot. So this really is a pathological thing, but we should fix it. So let's go and find the code that renders that frame. And here it is in rendering. We've got frame to scorecard. And you can see this is an extension function that looks at the type of every frame and decides how to render it. Here we're rendering roll to as a slash if it's a spare. Now we still want to render it as a slash if it's a spare, but in this case we aren't a spare. Let's see what is spare is defined as. And here it is, it's actually a method in bonus in progress final frame. And you can see here we say that we're a spare if our total pin count value is 10, but we don't ask whether the first roll was a 10. So I think what we'll do is we'll just say that we are spare if roll1.value is not equal to 10 and the total pin count is 10. Let's see how that does. Okay, still failing, but on the second one now. So we fixed the first one. Let's go back to rendering. Bonus completed final frame has the same issue. Is spare is defined here. And I think we should say the same thing here. We should say that this is roll1 value is not equal to 10, but the sum of the first two is 10. Run that. And we're good. I must say that finding a bug like that begins to shake my confidence in a code base a little bit. It wouldn't surprise me if we found another rendering issues like that. But let's at least commit this with fix final frame rendering where an initial strike doesn't mean a spare. Bit woolly words, but at least it's polished off. Okay then, now for today's proper task, which is to torture test our scoring. I pulled out the scoring specific tests here into bowling score tests, and you can see we've got two of them. The first one we wrote by hand because we knew the maximum score was 300. And so if we roll 12 10s, then we expect the game will be completed and the scores will be 300. And this list of is around the fact that we're playing a game with only one player here. The other scoring test we have is that a completed line with no strikes or spares scores the total of the pin counts. And here we let jQuick inject random small pin counts to us, which we then add up to give our final score. And a small pin count is defined to be something between 0 and 4, so that there's no danger of us scoring a strike or a spare. Of course, the problem is that strikes and spares are the interesting thing about bowling scoring, but I suppose it's not true that we don't have any tests for those at all, because we have these bowling tests that render a scorecard, and in these we've rolled strikes. This one is rendering spares, but you can see once we've rendered the spare, we do check the scores are as we expect. But these are example tests, and the problem with example tests is we only have the examples that we've dreamt up, and as we just saw with rendering a final frame strike, sometimes we don't have enough imagination to find bugs that are actually there. So back in the score tests, one way we might generate new test cases is to ask AI Assistant. So I think what I'm going to do is I'm going to say, let's take this thing as an example and let's ask AI Assistant to generate some more cases for us. So we've got AI Assistant generate code. Okay, so I find it helps to be polite. We'll say, please generate some more tests like this one for 10-pin bowling scores. Okay, so the generate command brings up a diff, and I've got to say, initial impressions are very good. It's generated minimum score is 0 with all gutters. List of 20 zeros, that should be list of scores 0. Well, that's very plausible. A perfect spare game scores 150. So if we have 21 fives, that again sounds very plausible. Let's have a look down, see what else it did. Oh no, just got rid of a blank line at the end. So I think we can accept all of these and try running the tests. Ooh, well, I must say it's very impressive, especially as this matches the style of the test we gave it as an example. I think I could probably have generated those two myself in not a lot less time than it took AI Assistant to do, but still very impressive. Let's try. Please generate more 10-pin bowling tests like this one, but with a mix of strikes and spares and normal frames. See how we get on. Okay, that was over a minute, so we obviously gave it something to chew on. Let's see what it's given us. Ah, well, that's interesting. So we get mixed pins is a 10, followed by 2 5s, a 3 and a 4. Well, it's a little complicated. I'm not sure it's right, but let's accept it. And try running. Oh, let's see what we got, shall we? So we're getting a cast class exception. We've got a completed game which can't be downcast to playable game. That suggests that it tried to roll too many things. Let's go and have a look at that test. Well, okay, I'm a little confused, I must say. It's not at all clear to me how many pins we are creating here. Let's find out by printing mixed pins, and we'll debug just this test. Ah yes, goodness me. I think we've actually started there with what? Is that 12 strikes? Followed by 12 fives. Well, we know that 12 strikes is enough to end the game. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, the game would be over by the time we get to here. So that's no good at all. Plus, even if it had done a good job, it's decided that the expected score is just the sum of the mixed pins, not accounting for all the special rules. Now, unless I'm missing something, one of the problems with the AI Assistant's generate code is that that can't then talk to it. We go to here, all chats 15 minutes ago, and no, these just seem to be empty. So close but no cigar that time. I think what I'm going to do is I'm going to delete this and we'll try the same thing as a chat. So I'm going to take this code here, AI actions, new chat using selection. That will do me. There we go. And now I'm going to say the same thing. Please generate more tests like this one for 10-pin bowling with mixes of strikes and spares and normal frames. And I think I'm going to prompt it a bit more to say, make sure that the score is calculated correctly. Let's see, shall we? This bottom one here is the same as we've got perfect spare game scores 150. It agrees about the score, but it's copied my style slightly less well than previously. Again, with no strikes or spares, that's rolling just 4s. Well, that's not a bad test, but it's effectively what we're doing down here with our property. So I don't think we gained anything from that. A normal frame followed by a strike. Well, that looks plausible. I'm going to take it and put it in here. Again, not quite the same style, but good enough. Spare followed by 3 pins roll. Again, don't know, but we'll take it. Strike followed by 2 pins roll. Well, I haven't got one of those. Let's see how that fares. Splendid. So we're making progress, although these do still seem to be quite easy cases to me. Let's ask for a harder one. What about alternating strikes and spares? Well, that's impressive if it works. I'm not quite sure about this mutable list of pin count. Let's just ask it to fix that. Can you not use a mutable list, please? Oh, I quite like that. Let's take it, copy it here, and put it in. And run. Oh, that's good. It's of course hard to know whether these scores are actually right. They agree with the scores that we've got, but we're asking two things to happen. We have to be right and AI Assistant has to be right. So we might be in danger of confirmation bias, but let's push on and ask maybe finally, are there any other nasty cases we should be trying? Okay, let's go back up to the top of that and see what it says. I can suggest a few scenarios might be worth testing. Minimum score, spare in the last frame, strike in the last frame. Neither of those two I think will be explicitly tested here, although we did have some of our bowling tests for those. Continuous spares and continuous strikes, I think we have covered that. 2 rolls in a frame adding up to more than 10. Well, we do have a test for that. But let's see what we've got. This one we don't need to do. Let's take this one, it looks useful. Interesting, drag doesn't work. Strike in the last frame allows for 2 extra rolls. Continuous spares score correctly, well we have that already, so I'm going to copy these into here. Continuous strikes, we've done that one, that's 300. 2 rolls in a frame, can't add up to more than 10. Well, I'm going to copy that and see what we get. Well, I think we're using a JUnit 4ism there. Let's ask it to fix it. How do I do the last one with JUnit 5? I'm not entirely sure about the style, but it will do. Let's copy it and put it into there. Import that, and let's run. I'm a little suspicious now. I only appear to be running one test. Let's go and make sure we're running all tests. Oh, there's the confirmation bias. It turns out that I was still running the one test that I was debugging earlier, I think. Let's go and see what actually... Oh my goodness, it seems that most things that AI Assistant generated for us aren't working. Let's find out what they say. Okay, now I feel like a bit of a fool. We're into exactly the sort of debugging that we don't normally have to do in test-driven development, where a lot of things are broken. I suppose at least there are any tests that are broken. I mean, we haven't changed our production code, although the test may be showing that the production code is broken. I think I'm going to go ahead and debug, if only to find out the sort of errors we're getting. So let's here, we'll println rolls, run just that one. And here we see the issue. We rolled a 10, that's good. We rolled a 5, but then we need to roll another 5 to make it a spare. What actually happened is we said we rolled 10 on top of a 5, but there are only 5 bits of wood to fall down, not 10, and our code has correctly rejected that. So unfortunately, let's get rid of that one. It's annoying that it was so plausible. Run all the tests again. Strike followed by 2 pin rolls. Well, it looks like in this case we completed the game too quickly. So here we scored a strike. That's 1 frame. These 2 will make another frame, so that's 8 frames left. So I think this should be 16. Is that true? It turns out yes it is, unless our code is wrong, but I think at the moment I trust that more than I trust AI Assistant. 2 rolls in a frame cannot add up to more than 10. Well, I think we were asking a lot for that to succeed, given that we haven't generated this error message. I'm not sure there's anything in this one for me. I'm going to delete it. Strike in the last frame allows for 2 extra rolls. Now we managed to complete this game, but the expected score was 110 and we said 160. I think I may need to appeal to authority rather than maths here, so Here's what Bowling Genius says, and who wouldn't trust a genius? It says the score from a run of spares followed by a strike followed by a spare is 160, which agrees with our scoring rather than AI assistants. So I think I'm going to say that test is perhaps useful as an edge case, but that we have to correct the score. Okay, spare in the last frame. Well, actually thinking about it, that is only the same as a run of spares, which we'd already scored somewhere, hadn't we? Ah, yes, there you are, 150. So it can't be both 105 and 150, but I suppose it's all the right digits, just not necessarily in the right order. So I don't think we're adding anything by keeping that test, so I'm going to delete it. Last one, maybe? Oh no, 2. Normal frame followed by strike. We again disagree on the score. And again, Bowling Genius thinks that our code is right, not AI assistant. Not a bad test, maybe. We'll make it pass that way. And go on to this one. Here we completed too early. I suspect that should be 15 instead of 16. Let's find out. No. Oh, I'm going the wrong way. I'm going to say 17. But we do at least agree on the score. Let's go back to making sure we're running all the tests. And 8 tests sounds more plausible. I'm not sure how I feel about these tests now we've got them. They largely feel a bunch more arbitrary examples, or things that maybe I would have generated myself, but I'm going to check them in for the record. So this is add AI assistant generated scoring tests fixed by a human. So if we're unsatisfied by just yet more examples, can we do better with properties? Now, there are some simple properties of scoring that we might test. For example, that the score in a frame is never less than the score of the previous frame. The score of a strike or a spare frame is always higher than 10. I can think of quite a few properties, but they all feel either too simple or too complicated to test. But if we had an independent arbiter of what the score should be for a game, then I guess we could just get jQuick to generate valid turns and see whether our code and the independent arbiter agrees. Effectively what I was doing with Bowling Genius, but a lot less by hand. So we could either do a clean room implementation of bowling scoring, or rely on the fact that there are enough examples of the bowling scorecard online for AI assistant to do a good job of it. The second one sounds easier, so let's ask, write code to score a bowling game given a list of pin counts. Well then, that's broken everything by putting it above the imports, and my goodness seems to be more complicated than I'd like. I'm going to ditch that, I think, and we'll go back to the chat. Let's try a simple function to calculate a 10-pin bowling score from a list of int representing pin counts. Let's have a look. Well, I'm not sure it's what I'd write, but here I'm going to take the wisdom of the crowds and reckon that the more mutable it is, the more it's likely to be right, because more people will have written it like this. So I'm going to take this. Oh, can't drag still. Oh, well, drag did work, it just didn't scroll. There we go. Copy that. And I'm going to put it into here and see whether it compiles. It does. First thing I'm going to do is remind myself that this was AI assistant unmodified. And now let's see how we can use that. Here in our properties tests, we've got a very simple valid game. So let's take that and move it into here. And we're going to need these providers to be in scope as well. So valid turns and valid final turn. Let's go to the properties test and find those. So valid turn. So we need to copy those into here. That needs to be public, and see whether everything compiles and runs. It does. Good. Just check, because I'm getting paranoid now that we are running. There are no errors in a valid game. There. Good. And now let's take these two as a variable, which is all turns, and we'll look at the type of that. So that's a list of turns, And I think we should be able to turn that into all rolls is all turns flat map it, which is a turn rolls. And if we're right, the type of that is list of pin count, which is good because we can now say our expected score is calculate bowling scores from all rolls dot map it dot value. And now let's just pull out something like this as the test down here, and that should be a score of expected score. And now the question is, do you feel lucky punk? Well, that's encouraging. Let's give ourselves a bit more confidence by println end game to scorecard, and I think in the end we'll add on expected score. Now we don't seem to be able to run just this one property, interestingly, so I'll run everything which still passes and look at, well, the thing we called there are no errors and no valid game, and that's very plausibly 0. I can believe that's 117. It at least looks like we're comparing the right thing with the right thing and generating some pretty random games. Splendid. So I think we'll rename this. Let's try not to claim too much, but we say the property is that the final score is the same as another calculation. A little bit of a tidy. I think we might say we don't need to know that. But if we didn't say that, we could add the map in here. That would allow us to say that. I think we might inline that. Move that after we've done everything and get rid of that. And once again, go back and make sure that we are running all of our tests. 32 of them. Brilliant. So that leads us to the question of what examples we want to keep. Let's go up and have a look. This property I think is a good one. It will be subsumed by this one if we throw enough examples, but it's a good backstop. This case is not really about scoring, I think, but I might leave. But this one here leaves me a bit cold. Ditto the spare. Normal frame followed by strike. Well, again, we're just rolling zeros. That's not very interesting. Perfect spare game scores 150. I think that's good. Minimum score is 0. I think that's good. Maximum score is 300. That's good. I might just reorder those for no good reason. And there we have it. We'll commit with add property based tests for scoring and remove some, I'm going to say, arbitrary examples. I think this should be private. Run one more time with feeling and commit. You know, I've just been sat here looking at this calculated bowling score, and I realised that I really have no idea how it works. I believe it's doing an interesting thing with the indexes, which feels as if it will work in the final frame if there are 3 rolls, and it agrees with the scores that we're getting. But if this was fly-by-wire software or a pacemaker, I think I might want to understand it better. Anywho, I think on that note we're done for the day. I think we've done 10-pin bowling to death, although I do feel maybe a review of how well this mix of type and test-driven development worked out for us might be useful, maybe just a bonus one. If you'd like to see that, then please subscribe to the channel. Click the like button so that YouTube keeps these episodes in your feed. And you might like to buy the book that I wrote with that price called Java to Kotlin, a Refactoring Guidebook, details of which are on the show notes below. Thanks for watching.